Hello everyone, welcome to this video. In this video we shall see certain questions related to the concept of finding out the maxima and minima of a function of three variables. So here in the previous video we saw that what is the necessary condition to find the extremum. So the necessary condition states that your first derivative partial with respect to x, with respect to y and with respect to z of the function f of x, y, z at that particular point a, b, c should be equal to 0. And we have also discussed the method corresponding to that. So the method says that firstly you will compute all these three partial derivatives of f with respect to x, y and z, and then you will substitute them equal to 0. Then you, by equating to 0, you have three equations in three variables. So you will calculate the values of x, y and z from those three equations, and thereafter in this case you will calculate capital A, capital B, capital C, capital F, G and H, whose values are these: the second derivatives with respect to x, with respect to y, with respect to z, and then the mixed derivatives, firstly with respect to z and then y, and then x and z, and then y and x. So by evaluating all these capital A, capital B, capital C, F, G and H, you will see what are the values of these, and you will check what are the signs for this capital A, the determinant of A, H, H and B, and the 3x3 determinant of A, H, G, H, B, F, G, F, C. Then when you have evaluated all these things, so based on the signs of the expressions A, and then this second order determinant and this third order determinant, if A and this third order determinant is negative and the second order determinant is positive, then we have a maximum at that particular point. If all three they are positive, then we will have a minimum at that particular point A, B, C. And if you have any other permutation or combination of all these three quantities, that means the signs differ from these two cases, in that case we will say we do not have any direct idea about the maximum or minimum expression from the given values. So for that we have to compute this d2f. What is this d2f? d2f is this expression f of x dx whole square plus f of y dy whole square plus f of z dz whole square plus 2fxy dx dy plus 2fyz dy dz plus 2fzx dz dx. Now once you compute this expression, you will again go for the sign of this expression. If you have this expression to be negative, in that case we have a maximum value. If this is positive, then we have a minimum value. And if the sign of this expression cannot be determined, in that case we will say we have neither maximum nor maximum, and in that particular case we will have a saddle point. So let us first discuss some examples. This question I left to you in the previous video. So here the question is to determine the extreme values of the function f of xy, which is given to be x square plus y square plus z square plus x minus 2z minus xy. Okay, so the first step is computation of these first derivatives with respect to x, y and z. So we can in the first case we can assume this y, z to be constants, so that your partial derivative becomes 2x, and then according to this term plus 1, and then according to this term minus y. And similarly you can compute the other two partial derivatives. We can substitute them equal to 0. Once you do that, you have three equations. The first equation is this one, 2x plus 1 is equal to y. Second one is 2y is equal to x. Third one is z is equal to 1. So we from these two equations we obtain the value of z is equal to 1. Now we have to solve these two. So when you solve these two, you obtain the value of x as minus 2 by 3 and the value of y as minus 1 by 3. So these are the three values, and we call them to be the critical values or the critical points. So this is our corresponding critical point. So now the next task is to the computation of these double derivatives. So we have already named them to be capital A, capital B, capital C, capital F, capital G and capital H. So how do you compute all these derivatives? Just differentiate the first order derivatives once more with respect to x, with respect to y, with respect to z, and then for the mixed derivatives you will differentiate this with respect to y, you will differentiate this with respect to x as required, right, for these expressions. So once you obtain the values of a, b, c, f, g, h, the next task is the computation of these at the given critical point. So this was our given critical point. So at this particular point you will evaluate what is your a. A is a constant. Actually all these are constant, so this point would not make any difference. So the values will remain the same. So from here we again have to evaluate this second order determinant and the third order determinant. The formulas for which are the determinant of a, h, h, b. So we have just listed the values here. The value of a was 2, so this is 2 here. The value of h, that was equal to 1, minus 1 actually. So using this expression you have the value of h as minus 1, and then the value of b, is equal to 2, so that means you have 2 here. Okay, so you solve this and you obtain the value as positive. Similarly for this third order determinant you obtain the value as a positive quantity. Now because all these, a is also positive, the second order determinant is also positive, and this third order determinant is also positive, therefore we will say we have a minimum value at this critical point. So what is this minimum value? This minimum value is obtained when you substitute this critical point into the given function. So once you do that, you have the minimum value as minus 4/3. So this is your answer. So let us see one more question. The question says we have to show that the function f of x, y, z, which is defined to be like this, has a minima at the point 1, 1, 1 and a maxima at the point -1, -1, -1. So in this case also the procedure is same. So we have our function. So using this function we can calculate the first order partial derivatives. So they are del f by del x, del f by del y and del f by del z. So we compute them. In the first case we'll assume and our y and z to be constants. In the second case we assume our x and z to be constants, and in the third case we assume x and y to be constants. So our partial derivatives are these. So we have substituted them equal to 0. So that means we obtain these three equations. So the next task is to solve these three equations and to evaluate the values of x, y and z. So once we equate them equal to 0 and you simplify this, you obtain two critical points. One point is 1, 1, 1 and the second point is -1, -1, -1. So these are the only points because these two variables are equal. The next task is evaluation of double derivatives. So we just evaluate the expression for a, b, c, f, g and h. And corresponding to these expressions we will also determine what is the value at the point 1, 1 for all these, right, 1, 1 and for this -1, -1, -1. So at both these points what are their values? So once you have these values, we'll proceed firstly for this point -1, -1, -1. So here you see what is your a value. Your a value in this case is -18. So a is negative here in this case, and the second order determinant that comes out to be positive quantity. So this is positive, this is negative, and the third order determinant is this one. So when you solve this, you obtain again the negative value over here. So that means according to the conditions, you have a negative, you have a positive, you have a negative. So that means you obtain a maximum value at the particular point minus 1 comma 1 minus 1 comma minus 1 because of the alternate signs. So that means you will have a maximum value here. And what is that maximum value? You can substitute this point in the given function. So it comes out to be a cube plus 6. So this is the corresponding maximum value of the function. Now for the point 1 comma 1 comma 1, our value of a that came out to be 18, which is a positive quantity. And similarly, we can compute the second order determinant and the third order determinant as well. So the second order determinant comes out to be positive, and the third order determinant also comes out to be a positive quantity. So that means you will obtain a minimum at the point 1 comma 1 comma 1. So this is what we were intended to prove. And what is that minimum value? So the minimum value is again the value a cube minus 3. So this is your minimum value when you substitute the point 1 comma 1 comma 1 in the given function. So in the question, they had only asked this thing. The thing we have to show was at this point 1 comma 1 comma 1 we have a minima, and at the point minus 1 minus 1 minus 1 we have a maxima corresponding to the given function. So I hope this is clear to you all. Well, that is it for this video. Thank you for watching.